Okay. A cone has a radius length 4 centimeters and a height of 2.4 centimeters. Calculate its volume. Okay, the volume of a cone, not to be mixed up with the volume of a cylinder, is a third pi r squared h. When you put that in, you're going to get a third. It tells us to, I think pi is going to be 22 over 7 for this one. Okay, so it's pi times 22 over 7. Oh, sorry, a third times 22 over 7. The length is 7 squared, and the height is.
We need the radius.
The height is going to be 2.4. Give me a second. Okay, so that's your set, and that's your 2.4 there, okay? Now, so put that into the calculator, okay?
Squared.
And what we get, and squared, don't forget the squared on the radius, okay?
Yeah, that's the radius. Oh,
Yeah, okay, so we're alright, into the calculator with it. You can see I more or less have a similar setup already. So all I have to do is change it into 7 squared and
2.4 squared.
2.4, and not squared, the height's not squared, okay? 2.4. Okay, what we get there is 616 over 5, which will change into 123.2. So the answer is 123.2 centimeters cubed. Now we have to find its total surface area. Now total surface area equals the curved surface area plus the area of one circle. So remember, the curved surface area is the part that, if you had a cone, it's the part that you can see. The circle on the ground, you can't see it, okay? So what we're going to do is we're going to add them together. So the curved surface area refers to this part here, just the cone part, like an ice cream cone without the circle on top, and then finally you have the ellipse on the bottom, which refers to the circle. Okay, the formula for this is pi RL for the cone part, and pi r squared for the circular part on the bottom. Now, problem is, what is L? Okay, so to figure out what L is, we have to do Pythagoras' theorem. And Pythagoras' theorem, this is me drawing basically a triangle to represent the cone. The length, the radius is 7, and the height is 2.4. So what I have to do here is I have to find out what is the length, okay? So what is the length there, okay? So, and I'll just put it down here now. Starting again, okay. Now, what happens here is we're going to be doing we're going to say that L squared equals H squared plus R squared. L squared equals 7 squared plus 2.4 squared. Put that into your calculator. 7 squared plus 2.4 squared. 7 squared plus 2.4 squared. Where's the squared button? There it is there. What we're going to get there is 54.76. We need to square root that. So square root up to the answer. The answer is going to be 7.4. How many people got 7.4 for L? Well done. Now that you got 7.4 for L, what we're going to get is, we're going to put that in. Pi is 22 over 7. The radius is what? What's the radius again? 7. And L is now 7.4 plus 22 over 7 times radius squared. Radius squared is 7 squared. Okay, what you get when you multiply all that out? 316.8. Did everybody get 316.8? Yeah, Jordan? Yeah. 316.8 centimeters squared. Okay. Next one. is number 13, okay? Number 13, okay, is a right circular cone. Has a height of 15 centimeters and a base of radius 12. Find its volume in terms of pi. Okay, for part 1, volume of a cone is 1/3 pi r squared h. 1/3, does it tell me what to use pi, in terms of pi? So use your calculator. Pi times 12 squared times 15. Okay, then put that into your calculator. So most of you should have got the first part of 13 reasonably alright. So it's pi times the radius is 12 squared and the height is 15. That's it done there. And 720 pi. Okay, so 720 pi. This represents the blue area, or the blue volume here, the volume of the full cone. Now, what we're asked to find out is find the volume of cone A. We want to find out what the red volume is. Now, there's a problem with cone A. Actually, the problem with cone A is we don't know its height, but we do know its radius. So we have to figure out a way to figure out basically what is the height of this cone. Now, what I told anybody who was here yesterday, what I told you was, if I draw a triangle in the center of this cone, what you'll see happening is the bigger you make the cone you're talking about, the bigger the height and the radius have to go up by the same factor. What I mean by the factor is, if I double the radius, I double the height. If I triple the radius, I triple the height. So what I need to do is I need to compare 8 and 12, and I have to figure out how many times smaller is it. Okay, so 12 divided by 8. So I'm comparing the new radius to the old radius is 1.5. The small cone is 1.5 times smaller than the original cone. So all what I need to do with the height is, I'm just going to get 15 and I'm going to divide it by 1.5. What's 15 divided by 1.5? 10. So the height of the new cone is 10 and its radius is 8. 10 and 8. Is that the same ratio as 15 and 12? It has to be the same ratio. What's 15 divided by 12? 15 divided by 12 is 5 over 4. What's 10 divided by 8? The new height divided by the new radius. It's also 5 over 4. 10 divided by 8 is 5 over 4. 15 divided by 12 is 5 over 4. That means you're correct. They have to be in the same ratio. Okay? Now that we have that done, what we've got to do is find out what is the red area. The red area is going to be 1/3 pi r squared h again. So it's going to be simply 1/3 multiplied by pi multiplied by its new radius is 8 squared and its height we just got is 10. Put that into the calculator. It's just a formula you use, okay? And then you multiply it by 10. And what we get here is 640 divided by 3 pi. So equals 640 divided by 3 pi. Can anybody in class tell me, hence or otherwise calculate the volume of the fulcrum, this part here. Can anybody tell me how to get the green area? Blue minus red. The big cone minus the small cone. So all I got to do now is I got to do 720 minus 640 divided by 3. So 720 pi minus 640 divided by 3 pi, and figure out what that is in the calculator. Does anybody already have that done?
Yeah. 15, 20 over 3.
What is it?
15, 20 over 3.
1520 over 3 pi. So 1520 pi over 3. Who got that one out of interest? Just Jack. Well done, Jack.
Very good.